quick ways to graph lines. The actual graphing of them, we won't do a whole lot of that in this lesson, but we need to have it on graphs so we can see what they're actually talking about. When I graph a line, for example, if I take the line and I do this with it right here, okay, let's say I have that line right there. Okay, well that line crosses the y-axis at that point and the x-axis at that point. Okay, so at that point where it crosses the y-axis, what are the coordinates? What would the coordinates of that point be where it crosses the y-axis, Larry? Okay, so it would be 0, 2. Okay, what would it be, Zach, on the x-axis? 2, 0. Okay, so those are our coordinates of those 2 points. Okay, we call this point right here the y-intercept. Okay, we call this point down here the x-intercept. Okay, now the y-intercept is where the line crosses the y-axis. At this point, the x-coordinate is 0. The x-intercept is where the line crosses the x-axis at this point. The y-coordinate is 0. Okay. So as we look at those 2 points, it doesn't matter if this line crossed here, here, even in the middle. Doesn't matter where it crosses that x-axis. Okay. It crosses here, so anytime it falls on this line, it could cross over here. Doesn't matter. Okay, it could be on the negative or the positive side of the x-axis. It still means that the y-coordinate is 0 when it crosses the x-axis. Okay, same thing on the y-axis. Wherever it crosses this y-axis, whether it's on the negative or the positive, x is going to be equal to 0. So, the definition of a line that we've talked about since 6th grade here, that I know of, because I teach that class, we've always said a line is equal to 2 points. Okay? When we were doing our table of values, we were coming up with how many points? 3 points, just to check, to make sure we did it right. Okay? Well, they're showing a way that we can quickly graph a line by simply finding the x-intercept and the y-intercept. Okay? So we want to look at some equations where we're finding these intercepts. Okay? For example, Brianna? The origin? Yeah, we'll talk about that on another day. The lines you're going to deal with today do not pass through the origin. Okay? Her question is what happens when the line goes right through there? That actually didn't go through there. Okay, that's what she was talking about, where it goes through the origin. Okay, those are what they call direct variations, and we'll talk about those, I think, on Thursday, if I remember right. Huh? All right. Let's look at a couple of equations here. Let me look here what ones I want to do. All right, let's say I had this equation right here. Let's say I had 3x plus 12y equal negative 84. Okay, I have that equation, and I want to come up with the x and y intercept. Okay, the x and y intercept. So, for the x intercept, we said y is equal to 0. So that's what we're going to do. We're going to make y equal to 0 in our equation. Okay, and so now we just work that out. 3x plus 0 equal negative 84. So it's 3x equal negative 84. 3 goes into 3, cancels 3 into 84. How many times? 28 times, so that'd be negative 28. So the x-intercept is equal to negative 28. Okay, so the coordinate then is this, negative 28 and 0. That's the answer to the first part. So, this is the x-intercept. The y-intercept where the y-intercept you have x equal to 0. So my original equation was 3x plus 12y equal negative 84. So that gives me 3 times 0 plus 12y equal negative 84. So that's 12y equal negative 84, which means I divide by 12, and y is equal to negative 7. And so my y-intercept then is 0 and negative 7. So if I was to graph that, okay, if I was to graph that, just some of these you're going to have to graph, some of them you're not going to have to graph. But if I was to graph that, it's going to look something it's going to look something like this. Let's say this is negative 7, negative 14, negative 21, negative 28, negative 35, And I get the same thing going down, -7, -14, -21. So, 0, -7 is right there. Okay, -28, 0 is right there. Then obviously I would draw the line through those 2 points. Okay, and that would be graphing it if they told me to graph it. Okay, some of these they're going to start off, of course, just like they do in most of the cases. They're going to start off step by step. They're going to have you find the x-intercepts, and they're going to have you find the y-intercepts. Then they're going to have you graph the x and y-intercepts given to you. Okay, and then they're going to ask you, okay, here's an equation. Find the x-intercept, y-intercept, and graph it. Okay, so they're going to do it just like we've been doing throughout this process with the equations and graphing them. They're going to start off with, fairly simplistic, and it gets harder and harder as the lesson goes on. Everybody look at number 36 on page 221. Number 36 says the x-intercept equals 4, the y-intercept equals 6. So they've given you all the information you need to know. Okay? All you have to do then is to draw a graph since both of them are positive, then all I've got to do is really draw the positive side of the graph like that. Then I just graph the 2 points. Okay, the x-intercept is 4, so that's 1, 2, 3, 4. So that's where 4, 0 is. The y-intercept is 6, 1, 2, 3, 4, 5, 6. And that's 0, 6. Yeah, I started from the origin, but that's 1. I just went 1, 2, 3, 4, 5, 6. Okay, and then I went from this way. I went 1, 2, 3, 4. But yes, you don't. In other words, you don't count right on the origin. It's not. The origin's not 1. It's 0, 0. So it has to obviously start at 0 then. And now, obviously, we just draw a line through it. Okay, and that's how you graph the x and y intercept, if it's given to you. Okay, so for like 35 through 40, that's how you would do that. All right, look at 14. Look at 14. What is the x-intercept on 14? Brandon? Well, on the x-intercept, they just want the x-coordinate. So what is the x-coordinate on number 14? 2. So that would be part of it. The next one would be the y-intercept. No. Where does it cross the y-axis? 3. And so that's your answers. Okay. X-intercept is 2. Y-intercept is 3. All right, now, if we look at number 17, number 17 says find the x-intercept of the graph of the equation. So I have x plus 3y equal 5. So the x-intercept is where y is equal to 0. So that would be x plus 3 times 0 equal 5. So x is equal to 5. So the x-intercept is 5. Okay, that's all you got to do. That's your answer. What about number 24? 24 says 2x plus 6y equal negative 24. They want you to find the x-intercept. So that's 2x plus 6 times 0 equal negative 24. And so that's just 2x is equal to negative 24. X is equal to negative 12. So that's all you have to do on that. Does everybody understand where I got negative 12? Now you can understand why solving equations was so important, last chapter. Now, number 26. Number 26 says y is equal to 2x plus, is that negative 2x? Yeah, negative 2x, my bad. Y is equal to negative 2x plus 5. So if we're finding the y-intercept, then x is equal to 0. So I have negative 2 times 0 plus 5. So y is equal to 5. So the y-intercept of that equation is 5. Okay, if you look at 33, number 33 says negative x plus 1.7y equal 5.1. So we just plug in 0 for the x. So negative 0 plus 1.7y equal 5.1. Well, that's just 0. So it's 1.7y equal 5.1. So I divide by 1.7. I move it once here. I move it once up top. So y is equal to 51 over 17, which is 3. Okay, so not real difficult. Okay. Larry, what can I help you with today? Okay, is this math class? Okay, we don't talk about cans in here. No, it's not. No, it's not. Nick? If you're finding the y-intercept, the x-coordinate has to be 0. If you're finding the x-intercept, the y-coordinate has to be 0. And basically, all you're doing is you're basically just doing a table of values, okay, where x and y are here, but the only difference is you're saying x is equal to 0 on one of them, and y is equal to 0 on the other one. That's all you're doing. Okay, to find the x and y intercepts, you're just creating a table of values where x is equal to 0 on one of the values and y is equal to 0 on the other value. All right. Now, let's take it from we've already done one. excuse me. But let's take it from step 1 all the way through. Let's say, for example, number 50. Number 50 wants you to come up with the x-intercepts, the y-intercepts, graph it, and then label your coordinates. Okay? So they want all 4 steps, basically. Okay? So number 50 says negative 4x plus 3y equal 24. So once again, like I just said, all you're basically doing is coming up with a table of values. X, y, where x is equal to 0. Okay, so if x is equal to 0, then I redo this equation. And so that's just 3y equal 24, which means y is equal to 8. So I plug in an 8 in my table of values. So now they want to know the y-intercept. So at the y-intercept, well, that was the y-intercept, excuse me. At the x-intercept, if the x-intercept, y is equal to 0. Okay, so this was the y-intercept right here. So then if x okay, so if we're looking for the x-intercept, y is equal to 0, so that gives me negative 4x is equal to 24, and x is equal to negative 6. Okay, so those are the 2 points that I have to graph. Okay, and like I've said in the past, draw your graphs like that. You don't have to draw, all 4. If it doesn't fall in all 4 quadrants, then there's no need to draw all 4 quadrants. Okay, with this, they're not obviously going to fall in all 4 quadrants. Okay, there's a y-axis point, which is positive, so I need to draw the positive part of the y-axis, and there is a x-intercept, which is negative, and so I really don't even need this part over here. I can just do this. I can do that right there is all I really need. Okay, and so my y-intercept is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that is 0, 8. As you can tell, I'm labeling my points with their coordinates. Brandon. No, I'm just reminding you. Well, that's fine. Just reminding. Since you didn't do it, since you forgot to do it earlier. What, Nick? Yeah, you could go by 2s, but if you go by 2s, then obviously you need to do it on both parts of the graph. You don't go by 2s on the y-axis and then go by 1s on the x-axis. But yes, you can do that to shorten up your graph. I don't have a problem with that. Larry? Because I don't want to. What? Right. Why don't I put that as the answer? In other words, right up there where it says x equal negative 6, why don't I put negative 6 and 0? Because that's not the x-intercept. Negative 6 is the intercept. The coordinates of the x-intercept would be negative 6 and 0. So we have 1, 2, 3, 4, 5, and 6. So there is negative 6 and 0. Okay, and then we just draw our line. Okay, now, realistically, the label for that line, eventually we'll start putting labels on it, but right now we don't usually put this. Okay, we usually put it in function form, but eventually that's what you'll start doing, is labeling the line with the equation. Brianna? Why? Mine does too, but no. Swallow. Get some spit, swallow. Well, you can take a mark, but I'm really not supposed to allow you to go outside and get drinks during regular class time. I've been instructed by the principals to only if it's an emergency. If it's an emergency, you can, but... Huh? No, you're dying. All right. So, that's how you do all 3 steps, okay? We obviously have, that's your step 1. Step 2 is the process here between the 2. And then step 3 would be the actual graphing of the intercepts. Okay, now, any questions on that? Any questions? All right. Your homework. 4.3. I've got to look at what I put on RenWeb. I can't remember. All right. All right. You have 14 through 54 even. And then 60, 61, 62. So 60 through 62.